x equals 3t squared and y equals 2t squared minus 3t. We want to find out the turning points and their nature. So let's get dx dt and dy dt first then. So simple differentiation, dx dt. The power rule, 2 comes down to be with the 3 to make 6t to the 1. Dy dt, differentiate that. If I can write t here, equals. The power rule again, 2 comes down to be with the other 2 to make 4, t to the 1, 1 less power. T differentiates to 1 and it's minus 3 lots of. So dy dx then is equal to dy dt divided by dx dt, so it's 4t minus 3 divided by 6t. Let that equal 0. That equals 0 when 4t minus 3 equals 0. And that tells us that t is equal to then, move the 3 over, and then move the 4 from times down to divide on the other side. We can do those 2 steps one after the other in one fell swoop. T equals 3/4. So at t equals 3 over 4, what do we get for our coordinates x, y then? Well, it's 3t squared, so it's 3 times 3/4 squared. So we put that in the calculator. 3 times bracket 3 divided by 4 squared, so everyone's on board, 27 over 16. And the other coordinate in here, 2t squared, so let's go back to minus 3t, so it's 2t squared, which we can put in here, minus 3t, minus 3 times the 3/4, wasn't it? 3 divided by 4, close bracket, equals minus 9/8. There we go. There's our turning point, just one turning point here. We need to look either side of 3/4 to see if dy dx, whether it's a max or min. And we need to bear in mind how as t varies through the value 3/4, how does x vary? It looks as though as t increases, x increases, doesn't it, around this value? So it should be straightforward. So here, dy dx, now look either side of 3/4. So it's equal to 4t minus 3 over 6t, which equals, now let's have a look, and I'm just going to write it down here, when t is just a bit less than 3/4, and I'm also going to look at t when t is bigger than 3/4. And let's have a look at it here. When it's just a bit smaller than 3/4, then this will be negative, this will still be positive. Negative over positive is negative. And for bigger than 3/4, this top line is positive and this is positive, so we get a positive. So dy dx is negative on this side of t, just under 3/4, positive on just a bit bigger than 3/4. Now since well, a bit clumsy here, as t increases around 3/4 value, so as we increase t around the 3/4 value, x is equal to 3t squared. That increases also. So we can read this off. This will be just lower x values. This will be higher x values corresponding to, that is. So on this side we've got a negative, which is like that sort of shape, and this side we've got a positive gradient. So we can see it's a minimum. So a min. There we go. So we've got our turning point then, which is here, and that's a min. So let's just check that on the plotter. So we want to do at t equals 3/4, we'll just do a little plot around that. Here's our parametric equations, so we can just type them in, can't we? So we've got 3t squared, so let's put it in here. So 3t squared, and then we've got what was the x? Y is 2t squared minus 3t. 2t squared minus 3t. There we go. So that looks fine. We're going to plot it around the value that we said that was the turning point, just to have a closer look at it. So the value was 3/4. So if we do from 0.5, say, which is a half, through to 0.9. Let's do a little plot of that. Let's see if we can see our turning point. Yeah, it's illustrated there on the sketch. It's a minimum, and it looks like it's a minimum at that x value and y value, and it's a min. So the x value was between 1.5 and 2, and the y value is just slightly negative, which is what I believe we had here. Yeah, something like that. 27/16 is about right. And minus 9/8 looks also good, and it's a minimum. So that's fine.